Hello friends, good afternoon. Welcome to CEC live lectures. This is our series in computer science that we are taking up different topics on computer science, and we go in depth into each of the topics. So we have recently completed our discussions on computer networks in a large number of lectures that we have undertaken. Today we are going to talk about yet another very important computer science subject or the area of specialization, which is the operating systems. So today's lecture is going to be an introductory lecture on operating systems, and as you would appreciate the concepts of operating system, we would migrate to advanced concepts. So basically this lecture can be useful for any of the students who are pursuing a bachelor's degree in computer science or even to an extent the master's degree, but today's lecture will be focused more on the basic concepts underlying the systems approach to computers and where exactly operating system will fit in that particular approach. So let us begin with the discussion on operating systems. So basically if we see what is an operating system, right? So we have been understanding and we have been looking at different components of the system, and we know that operating system is that program which acts as an intermediary between the user of a computer and the hardware. So operating systems they can have different goals depending upon what type of system it is. For example, if we are looking at a personal computer operating system, so then the main goal of that operating system would be to execute user programs and make the task of problem solving for the user become easier. Say for example, a user is interested in gaming, or a user is interested in browsing the internet, or the user is more interested in solving other problems using the computer. So then that kind of operating system is a different kind of goal the operating system will have. Whereas if we look at the operating system of a mobile phone or any mobile device like a tablet or a phone, etc. So here the operating system's main objective will be to make the system convenient and easy to use. Whereas if we look at the operating systems which are designed for say mainframe computers or mini computers or servers, so there the goal of the operating system would be to utilize the hardware in an efficient manner. So there the goal will shift from to resource utilization instead of problem solving or making the system convenient and easy to use. So therefore operating systems, they are designed with different purposes. Like some operating systems are designed to be convenient, to make the system convenient for the user, whereas other operating systems may be designed to make the system efficient for the user, right? So and there are yet another range of operating systems which have both these objectives, that is to make the system both efficient as well as convenient. So basically different systems will have different kind of needs for the operating system, different kinds of purposes, different kinds of objectives for the operating system. Now if we look at the structure of a computer system, so the computer system is actually divided into four main components. First is the hardware, that is the basic computing resources, the tangible components of the computer or the physical components of the computer as we may say, like the CPU or the memory or the IO devices, etc. Then the next component that we study is the operating system. Now what is the operating system? Operating system is it's a software, it's a logical entity which controls and coordinates the use of hardware among various applications and users. Then the next thing is application programs. So application programs, they will define the way in which the system resources are used to solve the computing problems of the users. For example, word processors can be there, web browsers can be there, database systems can be there, video games can be there. So there is a vast variety of application programs which are available, which is a very important component of the computer system structure. And then we have the fourth major pillar, which is the users. Now users need not necessarily be people, users could be other machines, other devices, or it could be other computers also. So users can be different entities depending upon what kind of environment we are looking. Basically a user will be defined as an entity which is using or making use of the computer system. So this diagram also makes it quite clear that actually the operating system, it sits in between the hardware and the programs, right, and the user interacts with the system, with the computer, by way of application programs. Now when we are saying system programs and application programs, definitely there is a difference between the two. We'll look at what is the difference, but the important point to note here is that you can not run the softwares, any softwares, on the bare hardware. You need a layer, you need a strata of operating system to create that interface by way of which we will use the hardware for the purpose of solving users' problems or giving the specific services to the user. So system and application softwares can be there. Now what is the difference between system software and application software? So the name itself suggests that system softwares are those programs which will be used by the computer system for its functioning or for attainment of its own goals. Say for example you have antivirus softwares, or you have different kinds of utility software, like you have disk defragmenter or disk partitioning software, or you can have various device drivers, you can have various kinds of other devices which you will other kind of softwares which are available. Whereas application softwares are those softwares particularly which are installed by the user to solve a particular problem of the user or to undertake a particular task. So these are the main difference between application and system softwares. Now in many of the discussions and discourses we see that operating system is also considered as part of the system softwares, whereas in some texts we see that operating system has been considered as a separate component other than the system software. That is why, because the system cannot work without the operating system. You cannot run any software unless an operating system has been put in place. So therefore operating system is generally looked at separately as compared to the other system softwares. Now if you look at the computer, now this is the layered approach, or this is the components of the computers that we are looking. Now if we look at a computer from the perspective of a user, right, from the people who are using the computer, or from the machine perspective also. So basically the user's view of a computer will vary according to the interface being used, how a user is interacting with the computer, or what type of computer is the user interacting with. So the first and foremost approach is the personal computer. So now most users, what they do is that they sit in front of a computer which has a monitor, which has a keyboard, which has a mouse, okay, it has a system unit, and such a system is designed for one user to monopolize its resources. So here the main objective of a personal computer is to serve one particular user. So therefore the objectives of this kind of operating system will also be different. So what will be the goal of this operating system, or of this computer? The goal will be to maximize the work. So operating system will also be designed to give ease of use, okay, and some attention may be paid to performance. Performance means that what is the speed at which calculations are being done, or what is the speed at which the computer is responding, or what is the response time, or what is the various metrics which are used for ascertaining the performance level. But definitely, because it is a single user system, so the operating system does not have to pay any attention to resource utilization. Why? Because all the resources are dedicated to a single user, to a single person or a single user application. So this is, so performance is important, but it is already optimized for single user experience rather than the requirement for multi-user. So if you compare a single user with a multi-user, definitely a single user system does not have to worry about the performance metrics. Whereas if we look at another type of system, say we look at the mainframe computers or the mini computers. Now what are these computers? These are basically, these could be servers which are accessed using the terminal. So you have one mainframe computer or one mini computer to which various users are logged in using their terminals. So what is happening is, at the same time multiple people are accessing the same computer. So these users will share the resources and they will exchange the information. So the operating system in such cases is designed to maximize resource utilization. So instead of maximizing work efficiency or performance, now the task or the goal of the operating system is shifted to maximizing resource utilization to assure that all available resources. Now what are the resources? CPU time is a vital resource, memory is a resource, input output is a very important resource. So all these are used efficiently, and no individual user takes more than the fair share which is allowed. So here in case of mainframe and mini computers, the goal of the operating system is maximize resource utilization. Now another type of system or another type of setup in which we look at computers or the user would look at computer is the workstations which are connected to network. So these are simple computers which are connected to each other. So these users, they have dedicated resources at their disposal, but they also share resources such as networking and servers. So in this case, it's like an amalgamation of single user and what we say is personal computer and a mainframe terminal kind of setup. So operating system here is designed to compromise between individual usability and resource utilization, because this architecture or this strategy is using both. It is using single user as well as it is using individual user as well as your sharing of resources between multiple machines or multiple users. Now another type of and computers which are very commonly used these days are mobile computers, which could be either laptops or tablets or mobile phones. Now here the user interface is basically it features a touch screen. So this is an entirely different kind of operating system that we are looking at. So most mobile computers are standalone units, as we all know, and they are connected to networks through cellular or other wireless technology. So mobile users will they have the mobile computers, they have different requirements. For example, they are running on battery power, so their power consumption may be one of the priorities, or the hardware has to be really lightweight. So the operating system also has to be developed for that kind of a machine or hardware architecture. So mobile computers will have a different kind of operating system requirement and operating system goal. So likewise, this is the user's view, that is from the end of the users, how does the computer look. So it could be either a personal computer, a mainframe or mini computer, or it could be a computer in a network setting, or it could be a mobile computer. Then another view of looking, or another perception of the system can be obtained by looking or by viewing through the system view lens. Now what is the system view lens? That from the computer's point of view, right, the operating system is the program which is most intimately involved with the hardware. So in this context, operating system is a resource allocator. That is, it is going to divide the resources equally amongst all the running applications or among all the logged in users. So, computer system has got many resources which may be required to solve a problem. The operating system acts as a manager of these resources. Again, the resources we have discussed, it could be file storage space, it could be IO devices, it could be memory, it could be CPU time. So, whatever the resources are, the operating system will ensure that the resources are equally divided, that is, all of them get the fair share. So, now because there are numerous and conflicting requests for resources, so therefore the operating system must also decide how to allocate them to specific programs and users, so that it can operate the computer system efficiently and fairly. So, if more than one user or more than one program is requesting for the same resource, then the operating system has to devise a mechanism so that the resource is efficiently and fairly divided amongst all the users. Now, operating system also emphasizes the need to control, that is, it is a control program, because we have various input output devices and user programs. So, there has to be a particular program or a particular authority which is going to manage the execution of different programs, so that there is no error and the use of the computer is also proper. So, therefore, the operating system can work, in this case it will be working as a control program in the system's view. So, now we understand that depending upon the system or the person or the perspective with which you are looking at, the operating system can have multiple goals, it can have multiple objectives, right. And therefore, now we are in a position to see or to define the operating system. But surprisingly, there is no completely adequate definition of an operating system. In many places you will see that whatever the vendor ships when you order an operating system is a good approximation. That is, whenever you whatever you get with your computer system, whatever the vendor sends with your computer system as a part of the software, that is the operating system. So, it is the one program which is running at all the time on the computer. So, this program is known as the kernel. So, basically when the computer starts, the operating system loads into the memory, and when you shut down the computer, it is the last program to exit the memory. So, therefore, for all the running time of the computer, the operating system is going to be there, it is going to be running all the time. So, now along with this kernel, there are two other types of programs which will also be running. First set of program, as we have already discussed, are the system program, or what we call as the system software. So, these are associated with the operating system, but they are not necessarily a part of the kernel. And then of course, you have application programs which include all programs not associated with the operation of the system. So, application programs are users programs. So, a system can very well work even if there is no applications program installed in it. A system can boot because the kernel has to be loaded for the system to boot, right. But many a times, as I already discussed this point, that operating system is also associated with system program in many of the discussion. So, if we look at the organization of a computer system here, so we can see that there is one common memory which connects multiple device controllers through a common bus. So, we have multiple devices, say for example, we have the disk, we have the mouse, keyboard, printer, monitor, etc. Now, for all the devices, there is one particular controller, right, the device controller, that is called. Now, it is not necessary that for every device there will be a single device controller. There are situations where up to 7 devices can have a single controller. So, therefore, we need to understand how the system has been organized for this purpose. So, computer system organization basically, if you look at a modern general purpose computer, it can have one CPU, it can have more than one CPU, and therefore it will also have a number of device controllers. All these device controllers are connected through a common bus that provides access to shared memory. So, memory is shared between all the different device controllers. Now, the CPU and the device controllers, they can execute in parallel, competing for memory cycles. Now, to ensure orderly access to the shared memory, a memory controller synchronizes access to the memory. So, we are looking at a situation in which the CPU also wants to access the memory and the device controllers also want to read the memory. So, in this case, they have to access the memory in a ordered manner, right, and there is a memory controller which is going to regulate this access to the memory. Now, computer system based organization. Now, in this case what we are looking at is a Bootstrap program which is loaded at power up or reboot. So, whenever we start the computer, a particular program called the Bootstrap loader, which is activated, and this Bootstrap loader is actually stored on a RAM, which is also known as the electronic programmable read only memory, that is EEPROM, and this is generally known as the firmware. The EEPROM is generally known as the firmware. So, when the system is started, when the system is booted, the Bootstrap program, it initializes all the aspects of the system and it loads the operating system kernel and starts execution. So, the first program to load is the operating system, and who loads the operating system is the Bootstrap program, which will load the kernel and start the execution. So, the Bootstrap program must know how to load the operating system and how to start executing that system, and it also has to locate the operating system kernel and load it into memory. So, Bootstrap program does all these activities. It will locate where the operating system is in the computer and it will load it into the main memory. Now, besides this, computer system operation also consists of various kinds of devices. So, we have IO devices and the CPU which can execute concurrently. We know that IO and CPU will work in parallel. Each device controller is in charge of a particular device type. So, each device controller also has a local buffer. Now, the CPU, it keeps moving data from and to the main memory and from the main memory to the local buffer. So, there is a continuous exchange of data which is happening from the main memory to the local buffers and from the local buffers to the main memory, and this is being done by the CPU. Now, input output is from the device to the local buffer of the controller. So, as we have seen that all the device controllers, they have a specific place called the local buffer in which they place the data, in which they handle the IO request. Now, device controller informs the CPU that it has finished its operations by causing an interrupt. Now, this word interrupt is very important because in operating systems this will be coming up over and over again, how the interrupt handlers take place, what is the function of an interrupt. So, we will be looking about that in the lecture also. Now, computer system the occurrence of an event is usually signaled by an interrupt from either the hardware or the software. Now, the hardware may trigger an interrupt at any time by sending a signal to the CPU. Now, usually by way of the signal bus, by way of the system bus, because we have seen that all the devices including the CPU is connected using the single bus. Now, software may trigger an interrupt by executing a special operation called a system call. So, if it is hardware, it is called as an interrupt, If it is through interrupt is triggered by a software, it is called as a system call. Now, the interrupts, they have got specific functions. So, when the CPU is interrupted, it stops when it is what it is doing. So, whatever the CPU is doing, when it receives an interrupt, it will immediately stop and it will transfer the execution to a fixed location. So, when it will come back, it will resume on this particular task. So, the fixed location will contain the starting address where the service routine for the interrupt is located. The interrupt service routine executes on completion. The CPU resumes the interrupted computation. So, interrupts are an important part of a computer architecture, because each computer, it has its own interrupt mechanism and several functions are still remaining common. So, the interrupt must transfer control to the appropriate interrupt service routine. So, with this we come to an end to this lecture. We will continue in the forthcoming lectures. Till then, thank you.